Hello students, welcome to Abhyas IIT Prep. Right, now in this session, I'm going to explain the detailed solution of JEE Main 2024 questions from the topic combinations. Okay students, right, here the question is, there are 5 points P1, P2, P3, P4, P5 on the side AB excluding A and B of a triangle ABC. Similarly, there are 6 points P6, P7 and so on P11 on the side BC and 7 points P12, P13 and so on P18 on the side CA of the triangle. Now, the number of triangles that can be formed using the points P1, P2 and so on P18 as vertices is. Okay, this is the question. Okay, students, now all of you try to understand this. Here, they given one triangle ABC. For that, we know the sides AB, BC and CA. Now, on the side AB, they are saying that there are 5 points. Okay, P1, P2 and so on P5. Right, excluding the points A and B. Next, similarly, on the side BC, there are 6 points. Next, on the side CA, there are 7 points. Okay, now we have to find how many triangles can be formed with the given points. That we have to calculate. Okay, students, now all of you see here, right? Now, first I am taking one triangle ABC. Okay, so this is the triangle ABC. For this triangle, the sides are AB, BC and CA. Okay, according to the given, so what they given here, on the side AB, there are 5 points excluding A and B. Okay, on this side, there are 5 points are there like this. Okay, 1, 2, 3, 4, 5. 5 points are there on the side AB. Similarly, on the side BC, there are 6 points. On the side CA, there are 7 points. Okay, students, now we have to find how many triangles we can form with these points that we have to calculate. Okay, students, so here for solving this problem, we have 2 methods. One is direct method and one more is indirect method. So in other words, indirect method nothing but we have to move in the opposite way. Okay, students, right, I will explain what is indirect method. It is easy compared to direct method. Okay, here already we know to form a triangle we need 3 points. Is it right? Or that means we have to select the 3 points. So if you observe, the total points are here, the total points are 18. Now from these 18 points, how many triangles we can form? Right, 18C3. Is it right? That means we have to select 3 points out of 18. So total number of triangles formed are 18C3. But in this counting, there is one error. What is that? So in this counting, the triangles formed by these points are included and these points are included and these points are also included. But with these 5 points, how many triangles we formed? Instead of 5C3, we get only 0 because all these points are collinear points. We know with collinear points, we cannot form a triangle. So that counting is also included here. That we have to subtract, means 5C3. Right. Similarly, from these 6 points also we cannot form a triangle. That is already included in this counting. That we have to subtract. So 6C3. Similarly, from these points, instead of 7C3 triangles, it will be formed 0 only. That we have to remove from the total. Okay, so yes, this is the calculation. Now after simplification, we get the answer as 751. Okay, here only the method is important. So first we have to understand the question. And one more method, direct method. It will take some time compared to this. So what is direct method means? To form a triangle, we have the cases. First, I will take one point from this side and this side. So that means 5C1 into 6C1 into 7C1. And one more case is, I will take 2 points from this side and 1 point from the remaining sides. So this is another method, but it is very lengthy compared to this. Okay, students, this is the question. Right here the answer is 751. Okay students, I am repeating once again. So why we are subtracting this? Because with the 5 points on which are on one side, they are collinear. With that points we cannot form a triangle that is included in this counting. So that's we have to subtract. Similarly for the remaining also. Now after doing the simplification, what we get here? 751. Okay students, right. Next. Now see the next question. First try to understand the given question. Let the set S equals to collection 2, 4, 8, 16 and so on 5, 1, 2 be partitioned into 3 sets A, B, C with equal number of elements such that A union B union C equals to S and A intersection B equals to B intersection C equals to A intersection C equals to null set. Now the maximum number of such possible partitions of S is equals to. Okay, so this is the question. Now here first see this set S. Okay, 1 minute. Okay, now all of you see the set S. Here set S is 2, 4, 8, 16 and so on 5, 1, 2. If you observe, every element of S is some exponent of 2. Is it right? So I can write this set S as like this. Now S can be written as 2, that means 2 power 1. Now 4 can be written as 2 square, 2 cube, 2 power 4 and so on. Now 5 and 2 can be written as 2 power 9. Is it right? Now if you observe, the number of elements in the set S will be 9. Is it right? That means number of S equals to 9. Right. Next, after that, what is given here? Now we are dividing, we are partitioning this set S into 3 sets. Okay, 3 sets A, B, C, such that here A union B union C will be equals to S and A intersection B, B intersection C, A intersection C is null set. Now what is the meaning of this? Here for A and B there are no common elements. Similarly for B, C and C also. That means for this question we can write, if we take the Venn diagram, I can write like this. Okay, so I am taking this as A, B and C. There are no common elements and if we combine all these, that will be equal to S. Now what it indicates? That means, so here we are dividing the elements of S into 3 equal parts means, so in each set A, B, C, the number of elements will be equals to 3. Is it right? Here already in the question they given with equal number of elements. That means now there are total 9 elements are there in the set S. Now I want to divide these 9 elements into 3, 3, 3 for A, for set B and for set C. Already in the previous session also I explained division rule. Now with this structure I can write the number of A's equals to 9 factorial by, right, 3 factorial into 3 factorial into 3 factorial. But here these 3 are identical, that means repeated thrice. So we have to write by 3 factorial. And here one more point is there, I can arrange the sets among themselves. That means distribution. Now how to distribute these 3 sets among themselves? 3 factorial. Okay, so here why I taken this 3 factorial, I will explain. For example, with the first selection I am taking the first 3 elements, 2, 2 square, 2 cube. Okay, 2, 2 square, 2 cube that are in the set A. I can keep these points in B set or C set. Is it right? So that means arranging among themselves only sets. So it will be possible in how many ways? For 3 objects, how many ways we can arrange among themselves? 3 factorial. Now after doing the simplification, now 3 factorial will be cancelled. Right? After simplification we get it as 1680. Okay, students, this is the question. Now in this problem, we are using division and distribution because the sets are different. Is it right? Dissimilar sets. So that's why we have to arrange the sets among themselves. So there are 3 sets. So we can arrange the 3 sets among themselves in how many ways? 3 factorial. Okay, students, clear? Right, this is the question. Right, now we'll move to the next one. Right, okay, students, now all of you see this question. Right, now the question is the number of triangles whose vertices are at the vertices of a regular octagon, but none of whose sides is a side of the octagon is. Okay, students, now try to understand this question. Here also we have to find the number of triangles. Okay, the mainly ambition is to calculate the number of triangles. Okay, whose vertices are the vertices of a regular octagon. Okay, already we know octagon means it is one geometrical figure having 8 sides. Okay, but none of whose sides is a side of the octagon. Okay, now I will explain. First, we'll take the octagon. Right, octagon means it has 8 sides. Okay, I am drawing. Okay, for example, this is octagon having 8 sides. Okay, I'm giving the name for this octagon A, B, C, D, E, F, G, H. Okay, having 8 sides. Right, now so here we have to find the number of triangles. Okay, so here now if you observe how many vertices are there for octagon, 8 vertices are there. Is it right? Right. Now to form a triangle, how many points we need? We have to select 3 points. Is it right? That means now with the vertices of this octagon, how many triangles we can form? 8C3 triangles we can form. Is it right? 8C3. But in this counting, there is an error. So what is that? Here the main condition is none of the side of a triangle is side of the octagon. So what it indicates, whatever the triangle we are forming, there is no common side to the triangle and octagon. That is our question. Okay, so it's right. So now I will subtract from this. So the ways which are having one side common to triangle and octagon. Right, now I will show one side common to triangle and octagon means, for example, if I taken the side AB, right? So in how many ways we can select another vertex such that they have one side in common. That means, for example, if I take G, then for this triangle, how many sides are common, beta? One side is common to octagon and triangle. That we don't want in this counting. Is it right? So that means, for especially when I considering the side AB, we can choose the points, we can choose the third vertex such that they have one side in common in how many ways? I can select G, or I can select F, E and D. Is it right? That means from one side, how many points we have? 4. Like this, how many sides are there total? 8. That means 8 into 4, that we have to subtract from this counting. That means 32 ways are there. For that, in the 32 ways, one side is common to the triangle as well as octagon. That I am subtracting here. And next I can take 2 sides as common. Right, now we will see 2 sides as common. Now how many ways are there such that they have 2 sides are common to the triangle and octagon? I will write the ways here. For example, ABBC. Is it right? When I consider the 2 sides AB and BC, now I can form a triangle like this. Now for this triangle, how many sides are common? 2 sides are common to the octagon and the triangle. That we don't want here. Is it right? So now we have to subtract from this. Like this, how many ways we get? ABBC is one way. Next BCCD. Next CD. right? CDDE. Like this, finally we can take HAAB. Is it right? In this way, we can take HAAB. If we count all these, it will be 8. Is it right? Total how many ways we get? 8 ways. That 8 we have to subtract from this total counting. Okay, students. Right? This is the question. Okay, students, I am repeating once again. Actually, octagon means it has 8 sides or 8 vertices. Now, from 8 vertices, how many triangles we can form? 8C3 triangles we can form. But in that counting, there is one error. Right? So, whatever the triangle we are forming, there may be a chance of getting one side is common to the triangle and octagon. And 2 sides will be common to the triangle and octagon will be there. So, that we have to subtract from this total counting. Okay, students, right? This is the answer. Now, after simplification, what we get here? So, the answer will be 60. Okay, students, clear? Right. Right. Now, we'll say the next question. Here, the question is, let 0 less than or equals to r less than or equals to r. If n plus 1 cr plus 1 is to ncr is to n minus 1 cr minus 1 equals to 55 is to 35 is to 21. Then 2n plus 5r is equals to. Okay, so yes, this is the question. Right? Now, all of you say this here. Before going to solve this problem, I will give one important result. We studied this result in binomial theorem. The result is, right, NCR. Okay, friends. Right? For example, I have a binomial coefficient NCR. Now, so in this NCR, if I need n and r separately, okay, so if I need n and r separately, we can write it as like this. N by r into, now we have to decrease 1. Decrease 1 is nothing but n minus 1 cr minus 1. This is an important result to prove. We use this result in finding the values of n and r in this question. Okay, students, I am repeating once again. NCR can be written as n by r into n minus 1 cr minus 1. Okay, so to remember this result, I will give one method. The method is, whenever we need n and r separately, when we need n and r separately, we have to decrease 1. That is the main thing. Means n by r into n minus 1 cr minus 1. We can prove this result by taking some examples in place of n and r. Okay, so it's right. Now, we'll see the given question. Here, the mainly condition is this one. Okay. n plus 1 cr plus 1 is to ncr is the n minus 1 cr minus 1. Alright. Okay, so here, now I'm taking, right, from this condition, I can write it as n plus 1 cr plus 1 by ncr equals to 55 by 35. This is what I'm taking here, these first two terms. Next, with the last two terms, I can write NCR by n minus 1 CR minus 1 equals to 35 by 21. Okay, students? Right. Now, observe here, this result will be used. If you see the numerator and denominator, especially the numerator. So, if I want to decrease 1, we get NCR. Is it right? To decrease 1 means first we have to write separately these two. That means, especially for the numerator, I can write it as n plus 1 by r plus 1 into, now we have to decrease 1. So with that, what we get here? NCR. By in the denominator NCR there. So now it will be cancelled. Now this equals to, after cancellation, it will be 11 by 7. Okay, students. Now after taking some calculations, cross multiplication, we get 7n plus 7 equals to 11r plus 11, or 7n minus 11r equals to 11 minus 7, 4. Now this is one equation number 1. Okay, similarly from this second one, see here also, if you write separately, there is a chance to get n minus 1 cr minus 1. Is it right? With the help of that result. Same here also I am taking n by r into, now we have to decrease 1. So n minus 1 cr minus 1 by n minus 1 cr minus 1. So this equals to some 35 by 21. Now it is 7 5s are 7 3s are. Now here this is cancelled. Now with that 3n equals to 5r. Okay students, 3n equals to 5r. If you take some r value or n value, right, with the help of these two on solving the equations 1 and 2, when I am substituting r value here, now it becomes 7n minus 11 into, what is r here? 3n by 5. That means 33n by 5 equals to, we have here 4. Now after calculation 35 minus 33, so that is 2n equals to 20, means n equals to 10. Now substitute n value in equation 2. Now from this we get r equals to 30 by 5 means 6. So finally n is 10 and r is 6. Now substitute in the required one. 2n plus 5r, that means 20 plus 5 into 6 30. Now 20 plus 30 50. So which is the right option? B is the right one. Okay students, in finding the solution in this problem, mainly we are using the result NCR can be written as n by r into n minus 1 cr minus 1. Okay students, understood? Right, now we'll move to the next question. Right, now all of you say the question. Right, here the question is, the number of ways of 5 alphabets can be chosen from the alphabets of the word mathematics, where the chosen alphabets are not necessarily distinct, right, is equals to. Okay students, here now after reading the question, what is understood here? That means we have to select just to choose it. That means we have to select 5 alphabets. Is it right? 5 alphabets we have to select from the letters of the word mathematics, right, such that whatever the 5 letters we are selecting, in that the letters need not be distinct. That is the condition. Okay, so that means we can select the same letters also in that 5 letters. Okay, so now how many ways are there in these selections? Now we'll see. Okay, here the word is 1 minute. Okay students, here the word is mathematics. Now if you observe in this word mathematics, m is repeated twice. So first I will write 2 m's are there in the given word. Next 2 a's. Next 2 t's. Next h, 1 h only. h e I c s. Total it contains how many letters? 11 letters are there in the given word. Okay students, now from these 11 words we have to select any 5 letters, okay, such that the letters need not be, right, need not be distinct, not necessarily distinct. Okay, here to select 5 letters from this given word mathematics, there are some cases are there. Okay, now we'll see what are the cases here. Right, now first I will take all distinct letters. Now first case is all distinct. I am taking all distinct letters. Okay students, now we'll see how many selections are there when I select only distinct letters. Okay, distinct letters means now we assume it has only one m, one letter. So that means totally how many distinct letters are there? If I treated it as one, it has one, it has one. So total 5 plus 3, 8 letters are there. Okay, so what is the meaning of this beta? Instead of 2m, I am taking only 1m only, 1a and 1t. So totally 8 letters are there. Now from these 8 letters, if we select any 5 letters, it will be distinct only. Is it right? That means how many ways it is possible here? 8c5. Okay, this is first case when I chosen all distinct letters. Okay friends, right, this is first case. Next I am taking the second case is 2 same letters, that means identical letters. right? Two same letters and three distinct letters. Okay, students, three same and three distinct. Now we'll see in this case how many ways we get. Right, two same means I will take right, there are three, these are three beta, contains two same letters, is it right? Now from these three units, these three groups, okay, these three groups, if I select any one group, so it contains two same letters, is it right? That means from these three I'm taking one group, I'm selecting one group, 3C1. Let us suppose with this selection I got two T's. Let us suppose two T's or two A's or two M's. Okay, so from these three groups only I am selecting one group. Okay, it will be possible in 3C1 ways. Okay, now I have two letters. Next I need three letters. Okay, so I need three letters means now what are the distinct letters here? Already T is selected here. That means now I can take one M, one A and these five letters. So totally how many are there? 5 plus 2, 7. Now from these 7 letters we need how many letters beta? Already 2 is selected here. So we need 3 more letters from the 7 letters. In how many ways it is possible? 7C3. So that means whenever we are calculating the number of ways of 5 letters such that 2 are same and 3 are distinct, we get 3C1 into 7C3 ways. Okay, so this is the second case. Now next I will take the third case. The third case is, right, the third case is two same letters, identical letters and one distinct letter. This is the third case. Now we'll see how many selections we can make here. Two same and one distinct. Okay, right. Now we'll see here same letter groups are 3. Now from these 3 groups I will select 2 groups. Okay, so in how many ways it will be possible? In 3C2 ways it is possible. Let us suppose with this selection I got 2 M's, 2 A's. Let us suppose. Okay, with this selection I got 2 M's, 2 A's. That means finally I have 4 letters here. I need one more letter from the remaining letters. Right, when we calculate from the remaining letters means now I will take 1 T. Okay, 1 T and these 5 letters. Totally how many letters are there? 6 letters. Now from that 6 letters we need 1 letter because already 4 letters I have. So that means now from the 6 letters 1 letter means it will be possible in 6C1 ways. Okay, students. Now is there any other case? Okay, other case is also there beta. 2 same. But with that I will get 6 letters. But we are choosing only 5 alphabets. Is it right? So finally these are the cases. Okay, students, now after simplifying it we get the answer. Now tell me 8C5. 8C5 is nothing but 8C3. Right, 8C3 means 56. Okay, students, now 3C1. 3C1 means 3. Now 7C3 you can calculate. Right, 7C3, 7, 5, 6, this is 35. Now 35 into 3, that is 105. Next, now here it is 3, 2 means 3C2 means 3 and it is 6, 3 into 6, 18. So finally 105 plus 56, 161 plus 18, 179. Okay, students, so which is the right option? Right, so the option is 179. Okay, students, the option C is the right one. Okay, students, we can take these calculations, no problem, but in these calculations there is no doubt. But writing the cases are important. Okay, students, that is the most important thing in solving the problems of permutations, combinations as well as in probability also. Okay, students, all these are theoretical questions. Okay, students, clear? Right? Now we'll see the next question. Alright, now all of you see this question. Here the question is n minus 1 CR equals to k square minus 8 into NCR plus 1 if and only if. Okay, so right, now all of you see this question here. So here also in solving the solution for this problem also we use that results. Okay, just now I given the result. NCR equals, we can write N by R into N minus 1 CR minus 1. Is it right? Okay, right. Here also, now in the given condition, I am taking N minus 1 CR to that side or NCR plus 1 to this side. Okay, for example, I am taking NCR plus 1 to this side. Now I can write N minus 1 CR by NCR plus 1 equals, here we have K square minus 8. Okay, right. Now if we observe, if I resolve the denominator, there is a chance to get the numerator with the help of this result. Is it right? Okay, now I am taking N minus 1 CR by, now I can write it as N by R plus 1 into, now we have to decrease 1. So with that, what we get here? N minus 1 CR. Right, now this and this cancel, equals here K square minus 8 is there. Now after taking cross multiplication, now R plus 1 by N equals to K square minus 8 is there. Okay, so it's right. Now I got finally this equation. Now if we observe NCR plus 1, in generally when we consider NCR, here the condition is R is varying from where to where? 0 to N. Is it right? That is the fundamental concept. NCR means R is varying from 0 to N we can take. Similarly, in the given equation, NCR plus 1 is there. Right, NCR plus 1 is there means now I can assume R plus 1 from 0 to N. Is it right? R plus 1 is varying from 0 to N. When I taken N to this side, so from the right inequality, I can write R plus 1 by N less than or equals to 1. Is it right? Now substitute here. Now this is also R plus 1 by N. That means this is less than or equals to 1. Now after this, K square minus 9 less than or equals 0. Now after doing the factorization, we can write it as K plus 3 into K minus 3. Right, K plus 3 into K minus 3 less than or equals 0. Now by the wavy curve method, already we know the wavy curve method. So from this factor minus 3, from this factor plus 3. Right, now it is minus infinity, it is plus infinity. Right, mostly is positive, plus minus plus. Here less than or equal, that means negative. In which region it is negative? Minus 3 to 3. Equal symbol is there, so closed bracket. Now from this what we are getting? K belongs to closed interval minus 3 comma 3. Okay, so yes, by using this condition. Next, in this problem we have one more condition, right? So if you observe, R plus 1 by N equals to K square minus N. R is positive and N is also positive. That means this total is positive. This total is positive means K square minus 8 is also positive. So K square minus 8 is positive means K square minus 8 greater than 0. Here also we can take the factorization. K plus 2 root 2 into K minus 2 root 2 greater than 0. Okay, now by the wavy curve method, right, from this factor we are getting minus 2 root 2 and here we are getting 2 root 2, here plus minus plus, right, greater than 0 means positive. In which region it is positive? So minus infinity to minus 2 root 2 and open interval 2 root 2 to infinity. This is from this we are getting. Now for these two intervals we have to take, we have to consider the common region. Right, common. So if we take the common, that will be, so 2 root 2 to 3. Okay, friends, you can take one more number line here for combining these two. Okay, I will write here number line minus infinity to plus infinity. What is the first interval indicates? Minus 3 to. So if we sketch, if we plot the numbers on the line, minus 3, next minus 2 root 2, 2 root 2, next it is 3. Okay, now the first one is closed interval minus 3 to 3 and the second one is minus infinity to this and 2 root 2 to this. If we consider, the common region will be this one or this one. But closed on minus 3 comma open on minus 2 root 2 is not given in the options. And we have one more region 2 root 2 open on root 2 root 2 comma closed on 3, that is given here. Open on 2 root 2 closed on 3. So which is the right option? Option A is the right one. Okay, students, understood? Right? So we'll see the remaining problems in the next session. Okay, so yes, thank you one and all. Thank you for watching.